Okay, today's problem is maximum ice cream bars. Okay, so what we have to do? It is given like in a summer day, a boy wants to buy some ice cream bars. At the store, there are n ice cream bars, and we are given an area of cost of length n. So there are n ice cream bars are there, an area of cost n is there. So each in ith item, by saying the cost of the ith ice cream bar. See, where the cost of I is the price of the ice cream bar. So the boy initially has coins, so that many of maximum coins he has. He wants to buy as many ice cream as possible. So the boy can buy ice cream in any order, doesn't matter in which order the n is given, doesn't matter. The boy can pick up any in order, any order. Written the maximum number of ice cream bars the boy can buy with the coins which he have. So what is the length of the cost? Cost is length is n. It is said like what is the value of n? Value of n is 10 to the power 5, and coins is also 10 to the power 8. Okay. So by reading this question, simply something comes in our mind. So this is seems like a DP, general DP problems, where I can buy the ice cream or not buy the ice cream and try to proceed for solving it. So if you're going for DP, so then there is one problem. See, the constant is very high. So in this kind of problem, take not take kind of DP problem, in the memorization we have to take how much of things like what is the current index we have to consider and what is the remaining coins I have. Okay, so remaining coins I have. So this is the this is in if I store something in a memory DP, we have to store this value. Okay, corresponding this value I have to store something. So this I index could be how what is the length 10 to the power 5. Okay, 10 to the power 5, and this remaining could be 10 to the power 8, because see, they initially have 10 to the power 8, then I buy something, I will buy subtract this one, 10 to the power 8 becomes it becomes something, then I buy again something, it becomes I subtract that price and it will become, so it will be 10 to the power 8. So total space it is required 10 to the power 5 into 10 to the power 8. It is too high. It is too high, too large. This amount is too large. So here we cannot go for DP, and it will be more time complexity. So can you solve this the problem without any other approach? See, this is actually a greedy problem. Even though it seems like a DP problem, but it is actually a greedy problem. So, a greedy problem, if we approach for the greedy problem, how could I solve the greedy problem? What is the way we solve the greedy problem? So, solving the greedy problem, what we take? We take the what is the most beneficial? We take that thing in the greedy problem. So, here, what is the my target? Target is maximize the ice cream, maximize the number of ice cream I have to get there. So what will be the my case? Like I have to buy as many as ice cream I can buy from within my coins, right? So obviously I will first buy the lowest price ice cream. See here, if eight you have the 8 rupees or eight unit of currency, and there are two set of ice creams of price 2 and price 1. Price 1, price 2, how many you can buy? If you going for buy for price 2 ice cream, you can buy only 4. But if you want to buy price 1 unit, so you can buy 8 unit of ice cream, 8 ice creams. So obviously the it is a generic common sense, the lower the amount, the higher the ice creams I can get. So let's see the example how to solve the problem. So let's say this one, this is the coins, this is the prices of the or the costs of the ice cream bars, and this 8 coins I have. How could I buy this? So as I told you, I need to look only the smaller prices first. So one, then I look for two is two. So best way to do that is sort the cost. So we sort it, it becomes one, then 2, 2, 2, then 3 and 4. Okay, so how many coins I have? Coins I have is 8. So what I can do, I can first check first index, 0th index 1. So 0, 1, 2, 3, 4, 5, 6, 7. I'll check for the 0th index. Is it? I can I buy this ice cream? Yes, because my coins are 8 and my ice cream price is 1. So I can buy that. Count will be. So count is nothing but how many ice cream I can buy. So I can buy this one. So after buying, I have to upgrade the coins. Coins become 7. Come to next index. Can I buy this one? This ice cream price 1. Yes, I can buy. Count becomes 2. This becomes 6. Can I buy this one? Yes, I can buy. So mm, count becomes 3. This become 5. Can I buy this ice cream of rupees 2 or a price 2? Yes, I can buy this. So it becomes count becomes 4 and price becomes 6. Can I buy this one? Okay. So yes, this price with 2 coins I can buy. It becomes 5 and it becomes 1. So can I buy this one? No, I cannot buy because coins are less than my current amount. So at this point, whenever I got one point, whenever in which point where my current price, current cost is greater than my coins, I cannot buy. So obviously it is a sorted array. My cost array is sorted array. That means from these points onwards, in the how many coins I will get in the future and furthermore, that will be obviously greater than my coins. For so whenever my current price is greater than my coin, from that point onwards, I cannot buy any candies or any ice cream bar. Sorry, I cannot buy any ice cream bar. So I simply stop iterating. And what is the count I can return? Now we can say that I have only one coin left. So can I adjust this one coin? So think of it, if I don't buy this one, so that time what will happen? So let me go back to our cases. So here, so currently it was 2 and coin I have 7, right? Sorry, not 6, I have 6. So you can think, let's don't buy this one. Let's buy this two, let's buy it. Let's buy. So count becomes 3, this 6 becomes 5. Then this is come 2 again. So 6 not 5, 6 becomes 4. Next, this buy, can I buy it? Yes, I can buy. I can buy and count becomes 4. This becomes, now I can buy these two. So this become 5. So this become 5 and this becomes 0. Now from this I cannot buy. See, what is the count? Count is 5. Doesn't matter we choose or not. So in the grid algorithm, the total count will be the same. So better to choose one by one. This will be easiest way. So doesn't matter my future to like what are the item I'm going to choose, what are the item I'm going to choose, doesn't matter like what I've chosen it not. So it will not increase in the DP problem. So it depends, like if I choose this one, if I choose this one, and if I don't choose this one, there may be possibility I can choose this one, but here that is not the case. So even though like it is a greedy case, in the greedy here you have whatever is the beneficial or what is the my goal is, I will do that. Doesn't matter in future what is the going is the situation. What is situation is I don't care. I will simply take the current solution, current optimal solution. So this is our greedy, in this case it is a greedy algorithm. So if I code this, like write a pseudo code this, let's say function maximum ice cream. So I see maximum ice cream. What is given? Cost array is given, costs array are given, and coins is given. Coins are given. Costs and coins. Is n also given? Let me check once. N shouldn't be given. No, n is not given. Yes. So how can I sort? So first I did what? Sort the item. So sort it. So coins, cost I have to sort. So cost dot sort. Then what I need? I need one count variable. Count variable to store the count. Initially it is 0. So right now I will iterate for each and every item, for each and every cost actually, for cost, for each cost in the costs, for each cost in the cost I am iterating. Can this cost is less than my price? If it is there, then I will buy it. If the current cost is less or equals to my coins, I will simply buy that coin. So for that I have to do two things. First, I'll increase the count plus equals to 1, and I will reduce the amount from my coins. So coins minus equals to the cost. Simple. But if it is greater, as I told you, if some at some point it becomes greater, this 3 becomes greater. So in that time, I will break the loop, because no need to further calculation, because from this point onwards, every item going to be higher than my current remaining coins. So in this the case, else simply break the loop. Break the loop. Okay, simple. So my loops end here. At the end, I am going to return the item. So return the count. What is the count I have? Simple function. Okay. So what will be the time complexity? Time complexity of the sorting algorithm big of n log n. N log n. Simple. This time complexity is big of n. So the overall time complexity is big of n n log n. Okay, fine. Space complexity. See, whenever we do the sorting, it takes some extra space. It takes some extra space. Big of n space is takes, if any kind of sorting. So if I ignore that space, then what is the space complexity? Space complexity is, apart from the space I need for sorting, I don't need any extra space. Don't need any extra space. So in that case, space complexity is big of 1. So obviously, please keep it in mind. You have to say that if I ignore my space for the sorting, ignore the space for the sorting. Space for the sorting takes big of n amount of time. Otherwise, if interviewer says like you have to mention the space of the sorting, you have to say big of n. It depends. It depends on either big of 1 or big of n. Okay. So things mostly our what matters most to us, the time complexity. It is taking big of n log n. Can we optimize this time? Like reduce some amount of time? So let's see what we could do. I'm taking same example. What we could do is, see, this is the, so every time what I was doing earlier, whatever the coins I have, I was checking each and every item, checking it and subtract it from this 8, correct? So every day I am checking this, but this is the, can we group it together and subtract it? Can we group it together and subtract it? Is it possible? So let's see, is it possible or not? Okay, let's take some more example. Like, let's increase the example. Let's remove this 2, add 3 here, another 3 here, another 4 here, and 5 here. Okay, I have just some edited, and also point I will add 3 plus 7 plus 10. My coin is right now 10. Why I did it, I will explain. So let's, how many 3s are there? 3 3s are there. 2 4 and 1 5. Okay, so 4 5 6 7 8 9 10. So in our previous case, let's see what will be the answer. So coins is right now, we have 10, and my count is initially 0. Let's see what is the answer in our previous approach. So 3 is there, so I can by 1, 9, I can count 1, count 2, reduce 1, reduce 8, then buy another one, count 7, then I can buy 2, this 2, so 4, 5, then I can buy another 5, it becomes 3, then I can buy 6 one, and this becomes the last candy, like ice cream, sorry. So it becomes 0, it becomes 0. So 6 I count, I can buy. So instead of doing one by one, can we group it together and group it together in the sense, group it together means, let's say instead of buying one by one, buying all the items of cost 1, that will be, my coins is initially 10. So if I count is 0, if I do this, I will check total count, total cost is, can I buy this? So yeah, total cost is 3. My current coins is 10. I can buy the entire bunch. Instead of checking one by one, I can buy checking entire bunch. So bunch, if I go it, count becomes 3 and it becomes 7. Then I will group it together. I will check, can I buy, and how good group I will see. So can I buy this? Total cost is 4. Current cost is 7. Yes, I can buy the entire bunch. So it becomes 3 to 2 is going to add it. So it becomes 5 count and it becomes 4. Sorry, 3, 3, yes. So can I bunch entire thing? Can I bunch entire thing and buy it? So total cost is 9. What is the current count? 3. So I cannot buy entire thing. So how many I can buy actually? I can say 9 I can do, and 3 I cannot buy. Okay, so how many I can buy? So in this case I can buy, if we divide 9, so what is my, sorry, what is my remaining is remaining coin is 3. What is the current uh, individual price of this branch? Individual price of this group is 3. So if I divide this current coin divided by 3, it will becomes me 1. So 1 I can buy. So 1 I can buy, and my 1 I can buy, and it becomes 6 and it becomes 0. The next time onwards I cannot buy anything. Whenever the it becomes 0, so the price will be higher this coin, so I will just simply break. So what then what should be the answer? So we can simply, like, we cannot check twice, or two things we can check. We can check simply, we can simply check whether this group I can check, and or if I buy the entire group, like we can check two condition. We'll know, like, frequency of 2, frequency of, let's say, I of, or cost. We can check, let's say, frequency of cost into cost. If it is less or equals to coins, then I will buy. Otherwise, if it is not, then I will check frequency. Not frequency. We can check the what is the current coins divided by what is the current cost. That many item I can buy. So there is a one shorthand is there to check both in the same time. So how could we check the both in the same time? Let's say cost is like how many quantities I can buy. I can buy one thing. See here. So minimum of frequency that cost, comma, and this coins divided by cost. This is a shorthand. How could I find it? See this one for this group one. Let's check from the beginning. How could we do this? So this one I need for how many things are there? 3. So frequency is 3. Okay. But if I do this formula, how many it becomes? Becomes coins is 10 divided by 1. It will become 10. What is the minimum? 3 is the minimum. For this group, group 1, I will take all the 3. Fine. For these two, why, how it becomes frequency is 2. Coins. See, I have bought the 3 3 ice creams, right? Then I have to subtract this. Now the coins become 7, not 10. The 10 divided by 2 How many will be the, if I take only the division, the result only, not the remainder, then it becomes 3. What is the minimum is that 2 is the minimum. From there I will take 2. From this set, what is the frequency? Frequency is 3. But how many I can do? It is 3. So I have bought 2 ice cream of cost 2. So 7 minus 4 is 3. Then 3. How many say I can say? Only 1. So I can buy minimum. So see, this is the minimum. So I can take the minimum 1. So what is the cost? Cost will be 3 plus 2 plus 1 is nothing but 6. So 6 is the answer, as you know. So for next time on, I don't need to check anything because coins become 0 or current price is greater than my current cost is greater than my, what should I say, my coins. So I cannot buy. So this is the approach. Now next question is like, how could I group it together? Okay. For this we use counting sort. Counting sort. If you know the counting sort, it's good. Otherwise, please see some videos. I am giving you the basic of the counting sort. So counting sort, in the counting sort, we don't need the array in the sorted manner. We don't need doing that because we don't. In the counting sort, we are studying the frequency. During the frequency. So I don't need the sorting. We can do the same thing using the unsorted in our unsorted array. How could you do that? We need a frequency array. So in the frequency array, what should we do initially in the frequency array? What is the limit of the frequency array? So in the frequency array, in the counting sort technique, we take the maximum element from this array and we do plus 1. So maximum element is nothing but 5. So we do plus 1 space array. So 6 array of 6 cell. 1, 2, 3, 4, 5, 6. 6 cell I can take. So 0, 1, 2, 3, 4, 5. So what we will do is simply iterate one by one by one. Okay, instead of 5, let's take 6. It will be much. You can understand another concept. So let's say 7. Let's say 7. So in that case, the number of cell will become increase. 7 means 8 number of cells I have to create. So 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, and I need 8 space. So let's write 0, 1, 2, 3, 4, 5, 6, 7. So a length of 8. What we simply do, the counting sort technique. See, this counting sort technique only works on the when the array have the only positive numbers. If it is array containing negative numbers, it will not store, because what we do here, the corresponding, like what is the current number is corresponding index, I will just simply increase plus 1 here. So initially everything is 0, so I will simply plus 1 in this place. Understand? So if it is a negative and is not possible, so it is not like the negative case we can't use the counting sort. So here why it is in counting sort I am saying, just think of it right now, we are storing the frequency and not sorting it, we are storing the frequency. So what happens here, initially everything is 0 as I told, like it will come in the 7, let's start iterating and storing the frequency. So initially I am in the 7, so it becomes 7 becomes 1. Then 4, initially it is 0, it becomes 1. 2, it becomes 1. Then 1, it becomes 1. Then again 1, it becomes 2. Okay. Then 3, it becomes 1. Then 2 again. This 2 becomes 2. This is running the frequency. 3 becomes 2. This 1 is 1 will become 3. This 1 will become 3. This then this 3 becomes again 3. This 3 becomes 3, and this 4 becomes 2. 4 becomes 2, and this 2 also 2. This is the total actually frequency. So this is 0. Initially these are the 0. So what we will do, we will start from the beginning. Now see, that group is now done. Now the grouping is done. What I was saying, the grouping is done. Okay, I shouldn't delete that group actually. So grouping is 1 1 1. 2, 2. Now if you just rewrite it like why, okay, let me explain using the counting sort technique. So counting sort means now instead of this is sorting. Now I can put 0 times of 0, then 3 times of 1 and 2 times of 2. This if I do right that place, it becomes a sorted array. So the array becomes sorted. See here, if I do 3 times of 1, 3 times of 1, then 2 times of 2, then how many 3 times of 3, 4 times of 2, so 2 times of 4, then 1 times 7, 1 7. So see, this is my array with the sorted array. That's why we show counting sort. This is the easiest kind of not easiest, time complexity is less because counting the array takes big of n time, because we're iterating through this and storing into the frequency plus plus. This is nothing but array. So iterating takes big of n and updating the frequency takes big of 1, and after that we just simply again putting the numbers in the same order it is appearing. But this is also nothing but this is the sum of this number is big of n. So that's why the total time complexity of counting sort is big of n. So if you notice right now the grouping is done. Now grouping is done. So what I will do, I will now iterate one cost at a time, one cost at a time, and then start iterating and check our algorithm. Okay, let's write the our pseudocode of the our algorithm. So let's say function maximum ice cream. I guess that the naming I have given. Maximum ice cream, maximum ice cream. What is given? Costs are given and one coins are given. Okay, I need what counting sort. So in the counting sort for this, I need a maximum item of my given array. So I need maximum item. Let's say maximum cost is max of costs. Simple. And after that, I have to initialize the this frequency array with 0. This let's say frequency. Yeah, this frequency is an array. Is an array of integer of size of max plus 1, max mx plus 1. Why? See here, because I have to increment my frequency. Like 7 is there, so if I create an index of 7, this will be this. Then I have to do my say -1 kind of that, so that I can get the correct value. So I don't want to that doing -1 and update in the -1 place. So instead of, I'll take one extra space so that I can simply update this frequency of 7. I can simply update that. So that's why I take one extra space. So and this is done. Then I have to fill this frequency array. For that I will just iterate for each cost. In the cost, I'll simply frequency, I will increase the frequency. So frequency of cost plus equals to 1. Simple. After that I need one variable to store the my final count. I'm going to return count is 0. So now how should I proceed? Okay, so now I will proceed starting from 1, because cost starting from 1 to 7 I have to start. So for cost starting from 1 to cost less equals to my maximum cost. See, this is the maximum cost I have, so I have to iterate the maximum cost, and cost plus plus. There are two cases. So what is in the case, what if my cost is actually 0? If cost is 0, what is the formula to buy one candy? The formula is, so buy one candy. So candy buy formula, as I notice I removed this plus, but the formula I have written minimum of frequency, this frequency of cost, frequency of this cost, comma, this coins, remaining coins divided by current cost. This was the formula. See, but the cost, this current cost, this cost can be zero, right? The sorry, no, cost cannot be zero. But if it is zero, I don't need to check anything, na? So we don't need to do any calculation. So we can skip that part. So I'm saying like if my frequency is frequency of this cost is zero actually. So no need to do any kind of calculation, no need to do any overhead, and simply will continue. Okay, so simply will continue. So if I this is the buy means this is the number of candy I can buy. So I have to add in my count. Okay, so count will be count plus equals to this number of candy I can buy. Count plus equals to number of candy I am buying, and I have to reduce my current coins. So coins minus equals how many candy I am buying. This buy number of candy I am buying. What is the cost of each candy? Nothing but cost. So into cost. This thing I am going to subtract from my coins. Okay. So another condition is there, as I told you, like if sometimes my current cost is greater than my coins. So that time also I will not do anything. So let me write the condition here as well. Another case, if my current cost is greater than my coins, so that means I cannot buy anything. I'll simply break the loop. Simple that. So and I can solve this. Fine. And at the end I can return my count. Number of count I am going to buy. Okay. This is the case. What is the time complexity of this problem? The time complexity of this problem, see this one, taking big of n time. Okay. This one is not big of n time, big of maximum coin, maximum cost, big of maximum cost. So obviously this is less than big of n. Okay, or at most both are similar, because let's say everyone 1 2 3 4 every cost is like this way. So in that case it could be, at the worst case it could be big of n time. Okay, so and others are big of one amount of time. So time complexity is big of n, simple. And space complexity, so space complexity, I am creating an extra array of maximum of coins. So big O of maximum coin, maximum cost, not coin, maximum cost. So this is a space complexity I am taking, but it could be, at the worst case I told you, it goes to big of n, because let's say my cost are 1 2 3 4 5 6 this way 7. So this is the number of element and this is the number of cost. So at the worst case everything will be like each individual cost, like unique cost is appearing only once. So that case the space complexity will take big of n amount of time. Hope you understood the problem. So this is the solution of this problem. As always, if you find any mistake in this solution, please let me know so that I rectify. And if you find any useful information on this same topic, please let me know so that I can learn. Thank you. Bye bye.